having phi tilde to be just an identity map.
Yeah.
If phi tilde is an identity map, then those two M and N space, those are actually same space, same, and P tilde prime and P tilde are same point.
Yeah. Yes.
So in that case, for the same point P, we have two different kind of coordinate setup. One is x coordinate, another is x prime coordinate, and this relation still tells us between a relation between those two as phi tilde as an identity. So that is basically x prime composed with x inverse.
Yeah.
So when phi tilde equals to identity map, then this thing becomes just x tilde prime composed with x tilde inverse, which actually gives the relation between. Can you give me an example for this kind of situation? Can you give me an example?
From
Say in polar coordinate,
yes.
Cartesian coordinate, in flat space, Cartesian coordinate and polar coordinate are related by this relation, like x equals to r cosine phi, y equals to r sine phi, like that.
Yeah.
So you are taking r and phi on one space, and that is actually producing your xy. So xy would be your p tilde prime x prime, and p of x would be your r phi.
Yes.
Okay. So now let's see. I do not have much time today. Next day I'll start with one form and vectors. But today we'll just learn what about the numbers, scalar fields. So what is basically a scalar field is, it's a distribution, right?
Yeah.
It's a predefined distribution of numbers over here. So it's a map. Scalar fields are maps from space M to a real number line, because each of the point on space M maps to a specific point on real number line. Actually, I should write other way.
Okay.
So this is your real number line. Say it's 0, it's 1. So at this point, it connects to this.
Then this mapping is not one-to-one, right?
No, obviously not.
Yes, because their cardinality is different.
Yes, not all map can be like one-to-one. Not all map may have correspondence, like one-to-one correspondence. So
yes,
we are actually not thinking about that as well.
Okay.
All we're thinking about what would happen if this is our space N, and this is our space M, and M space has a relation to N through phi, and this map is F.
Yes.
What is, so here is a point like P tilde prime, here is a point P tilde. So mapping F, it takes P tilde prime and produces a real number, right?
Yeah.
So F is our scalar field.
Yes.
And let's call at a specific point, F has a value like F, this thing. That's the specific value of F at a particular point in a physicist notation.
Yeah.
Okay. So question is what's the relation between, like, what's the map that connects here to the same point there.
What is the map that connects P to
P tilde to that point f of P tilde prime.
okay, so we can at first go from P to P tilde prime, then P tilde prime to F. Sorry, P tilde prime to R. So it will be like if we apply phi on P tilde prime, and yes, this thing, and again, yeah, there's the thing, yes. Yes.
Right?
Yeah.
This is the answer, right?
Yes.
So, which is basically nothing but in our usual notation, f of p, instead of p tilde prime, we just write phi tilde of p. Or in other words, that's basically phi composed with is the notation correct?
Yes, I think so.
Yeah, probably, yes. So this is the thing of like this is the very definition of our pullback. So pullback of f, which is usually written as wait, pullback is upper star or lower star? I think it's upper star. So that's the notation of pullback. Push forward is the lower star. So that's actually this thing. F tilde composed with
Yes.
See, F was first distributed over n plane. Now, F tilde composed with F, phi tilde composed with F, that's actually now distributed over P tilde plane. So, F tilde, it's a field again, but it takes P tilde as an input, where F is the corresponding to that, which takes P tilde prime as an input.
Yes. Hello.
Yes.
Oh, okay. Bhai, I have to go. I have a immediate work now, so
Okay.
I'm just recording the last part.
Okay, actually, I'm not going to teach any more new thing today as well.
Okay, but it's still.
So this is for the scalar field. We can actually discuss some example, because if I start teaching about one form, I cannot finish. I have to teach it again next day. So or you can like end today's class here. It will be 8 minutes early. Hello. If you have any question, you can ask. Actually, I'm not going to introduce anything.
No question here. It will be better if you just stop it here. For me, actually.
Okay, let's for today. Let's finish here because I'm not feeling well as well today.
Okay.
Okay, bye. See you next week. Probably I'll feel better a little bit by then.
Okay. Thank you.
Okay.
See you next week.
See you next week. Bye.
Thank you. Bye.